Hey there folks, welcome to the first lesson on trigonometry. And I know what you're probably thinking. You're thinking, oh my goodness, this is going to suck. Well, that's not actually true, and I can prove it to you because the amount of fun we're going to have is actually buried within the name of this unit itself. Just going to rearrange some letters here, and I think you'll find that we are going to have more fun than a bag of farts at Christmas. So hold on to your hats and your pants, because here we go. Okay, well, we're going to start looking at something called the tan ratio, or the tangent ratio. So tan is just short for tangent, but typically we just don't really say tangent, but that's what it is, which is why they have it abbreviated on your calculator. It has absolutely nothing to do with, the angle of the sun and tanning and whatnot. Well, I mean, I guess it could, but that's not what we're talking about today. But what we can do is you can sort of look at this triangle that we've constructed here and look specifically at the common angle that they all share. In fact, there's two of them. There's this angle here, that these are all right triangles. They don't share that angle, but there's all a right triangle in a right angle rather in each of the corners there. So these are all right triangles, and the nice thing is we're always going to be dealing with right triangles for this section. So you don't need to worry about anything not being a right triangle. If you don't have a right triangle, you can always make it into one, which means that Pythagoras' theorem, a squared plus b squared equals c squared, applies to all of these as well. But that helps you find sides, but the tangent ratio can also help you find angles. So let's look at the angle specifically here, and that is the one that is here, right there. Okay, that angle there is common to all three triangles. All three meaning there's this one small triangle here. It's the same angle for this bigger triangle there. And then there's also a third triangle, this big one here. They all share that same corner angle. I'm actually going to give it a special name. I'm going to call it theta. Okay, theta is a Greek letter. And if you were in Mrs. Jones' class, she'd say it theta, but you're not in her class. And it looks like an O that has just been extended a little bit. You kind of make an O, and then you just kind of keep going, and then whoosh, you kind of cut right back through a little shortcut there. And that's what theta is. Okay, so let's look at theta, and let's more specifically look at these three triangles and their dimensions. And if you want to take the time to count the squares to double check, you can, but there they are there. Have a look. So the tangent ratio is just basically defined then as a ratio of these side lengths, because if you'll notice, these are all similar triangles as well, which means the ratio of sides, of corresponding sides rather, is the same for all three of them. In other words, the length of the triangle, the base, is always like 33% bigger than the height, right? So 33% more than 6 is 8, 33% more than 12 is 16, more than 18 is 24. So they're similar triangles, and that ratio is consistent for whatever this angle is here, theta. So we have to kind of look at those sides and sort of write that down somehow. And because these are all right triangles, they do have a special side that we all know called the hypotenuse. None of these sides are the hypotenuse. The hypotenuse is this big long side here for the big triangle, and then some portion of it for the smaller triangles. So the other sides then are this side here that's across from the angle, and this side here that's next to the angle. And so we have to kind of come up with a name for those. And what we call them, well, quite honestly, is the opposite side, and not the next to side, but the adjacent side, which means next to anyways. And that is what the tangent ratio is. It's just for a particular angle, the opposite side divided by the adjacent side. I want to show you another example and kind of demonstrate a bit more clearly what this means. Make sure you have a calculator with you, by the way, for this next section. Okay, well, we're going to look at another triangle here, but this time I know what the angle is. Okay, and the reason why I picked this angle, or this particular triangle, this is called a 30, 60, 90 triangle, because those are the three angles, and I know that it has special properties in that the shortest side here, if it's 1, then the longest side, the hypotenuse, is 2, and this is root 3. Okay, so I could make any variation of this triangle, make it bigger, for example. If it was twice as big, it would have those dimensions, but we'll just kind of stick with the smaller one just for clarity's sakes. So what I want to do is I want to look at the tangent ratio for that angle of 30 degrees. In other words, the tangent ratio for the angle 30 degrees is equal to the opposite side, which is the side that the angle sort of looks at. I tell my students to imagine that there's a creepy eyeball in that angle there. And the creepy eyeball, ooh, with little bloodshot eyes, and it's looking across at an angle. The creepy eyeball always looks opposite to the opposite angle. So the opposite side there then is 1. 1 is the opposite side. The adjacent side, so this is, both of these sides are next to that angle, both the 2 and the root 3, okay? But the adjacent angle is the one that's not the hypotenuse. The 2 is the hypotenuse, the longest side. That's always easy to identify. The one that's next to it is this one here, so the square root of 3. Okay, so you have 2 things you need to do in your calculator for me right now then. I need you to, first of all, figure out what 1 divided by the square root of 3 is. Go ahead and do that now. And you should have got that it was 0.577 plus a bunch of other numbers that we don't care about right now. But that's basically to 3 decimal places. Now what I want you to do is somehow in your calculator you're either going to hit tan 30 or 30 tan depending on the calculator you have. This is the computer calculator I have here, and for this one I have to go 30 and then I hit the tan button right here, tan, and look at that, 0.577, just like the 1 divided by root 3. That's not a coincidence, by the way. Okay, in other words, your calculator is pre-programmed with all the tangent ratios for all the angles we're going to be dealing with. You can do it for any angle and you'll get some decimal. In other words, a tangent of an angle is just a decimal. It's a ratio. It's a fraction. But it's in decimal form, and I know you love that. Why are we going to do that? Well, because that allows us to actually find missing sides of triangles. And I know you're thinking this is really lame, but it actually has a lot of practical applications. So in the forestry industry, a forestry surveyor will go into a section of the forest and try to determine the volume of wood that is located within a certain area in the forest. It's a big, long, complicated process, but at the very core of it is estimating the volume of wood in a tree, because a tree is just a big cone. And to do that, they can measure the diameter just by sticking a big rope around and whatever and dividing by pi. But to determine the height, they can't climb the tree, so they figure out the height of the tree using a tangent ratio, just like this. So the little worker guy stands at a set distance away. He grabs a rope with him, measures out 100 meters, let's say, for example, and then he has a little device called an inclinometer, which is basically a little tiny telescope with a protractor in it, more or less. It tells you what angle you're looking up at into. And inclinometers, you can get them for your iPhone. You can make your own out of a protractor and a piece of string. Very simple device. So our little forestry worker dude looks at the top of the tree and determines the angle of elevation. Let's just say it's 35 degrees. Now he knows 2 pieces of the puzzle, of which there are only 3 pieces. He knows that the tangent ratio for a 35-degree angle is equal to the height of the tree, which in this case is the opposite side of my right triangle, divided by the adjacent side, or the length that he's standing away from the base of the tree, so 100 meters. Okay, so in other words, he has tan 35, which on your calculator is just a number, and the base of this triangle, or the distance from the tree, is 100 meters, so h is the only unknown. All you have to do is multiply both sides by your denominator, and it magically disappears, and you get the height of the tree. So there we go there, and the left side is just a bunch of numbers you multiply together. 100 times tan 35. Try it on your calculator. Make sure you get 70 as your answer. If you get a different answer, a weird answer, like if you get like 47 or something like that, then your calculator's in the wrong mode. It has to be in degree mode. That's those 3 little letters at the bottom of your calculator. It's either DEG, RAD, or GRAD for degree, radian, or gradient. You want it in degree mode, so make sure it's done that. Okay? So that's it for this video. The next video from last year, I have it, but it's still very valid. It has a whole bunch of examples of how you can use this, and one for you to try in the homework for tomorrow.